So here we have the graph of leaf litter decomposition that we created earlier. We have points for each percent mass loss and a line that represents the mean. The mean for one treatment is higher than the other two. So we think that overall, this type of leaf litter decomposes faster. But as you can see, there are a lot of other data points high and low in each of the leaf litter types, especially with a non-native plant type down here. So how can we be sure that this mean or this average shows a real difference? Could it be higher just due to chance? Well, one way that we can figure this out is to add a standard deviation to the graph. To add a standard deviation to the graph, select the standard deviation in the toolbar on the right. So again, you can go ahead and click on this ruler, look for standard deviation, and then toggle that on. This creates lines above and below the mean that are a standard deviation away, and they give us a visual idea of how spread out the data is. As you can see, one treatment was more spread out than some of the others. If all of our measurements were close together and the standard deviation is small, there's not as much random variation. If the standard deviation lines don't overlap, then most likely our results show a real difference between the different treatments. If the measurements were really spread out and the mean wasn't that far apart, you see a lot of overlap in the standard deviation of one and another type of treatment. That means that there is a chance that our data didn't have significant trends. There may be too much random differences to say for sure if our results are real. For our results to be considered statistically significant, we don't want these bars to overlap. Ideally, for us to be able to say that our results are highly significant, there would even be multiple standard deviations between these bars. So go ahead and add the standard deviation into the multiple graphs that you created to see if your results were significant.